Kia ora koutou. Here's question 1E from this year's Differentiation Level 3 exam. So let's start off just by having a bit of a look at the question. It's a pretty straightforward one for what I'm assuming is an excellence question. We have to find the equation of the tangent to a curve at the point P. So we're given this curve here, and we're told that x has to be greater than 0. And we're told that the curve has got a point of inflection at the point P, and find the equation of the tangent to the curve at point P. So the first thing to notice in here is that there's a restriction and x has to be positive. Now let's look at why that is. Well, the first thing to notice is that in the denominator we've got x, so x cannot equal 0, or that function will be undefined. And then the second thing to notice is that we've got the natural log of x in here, and that's defined only for strictly positive values of x as well. So because this really is a straightforward question, what I want you to do is to just write down the 6 steps that you need to get the whole way through this problem before we get into it. And I'm going to put my 6 steps on the next page. So then pause the video, write down the steps, and then have a go at the question. I'm going to work through the question, and at the end I'll show you a graph to show you what it all looks like. Okay, so the 6 steps that I had were, first of all, we need to clean up the function because we've got an x in the denominator that we can simplify. The second thing we need to do, because we're finding a point of inflection, is we're going to differentiate the function twice. And after we've done that, we're going to solve the second derivative equaling 0, because we need that to have a point of inflection. And then we're going to find 2 things to find the equation of the tangent. We need to have the y coordinate at point P, and we need to have the gradient of the line also at point P, and then we'll use y equals mx plus c to get the equation, or we could use y minus y1 equals m times x minus x1, whichever of those is your favourite. Okay, so let's go back to the equation and get into it. So step 1 is cleaning it up, and we can rewrite it as y is equal to 2x minus 1 over x minus 2 times the natural log of x, and we can do that because we know that x is greater than 0. Right, what's the next step? Well, I would rewrite that straight away with a negative power. Next, we're going to do step 2, which is to differentiate twice over. So dy by dx is equal to 2 plus x to the negative 2 minus 2 over x. And again, rewriting that with a negative power. And at this stage, it's worth checking. Just pause and check that you haven't mucked up any signs. So look back over your work and do that. And then go on and differentiate to get the second derivative, which will be negative 2x to the negative 3 plus 2x to the negative 2. And we need that to equal 0 for a point of inflection. So step 3 is to solve this. We can rewrite it as 2 over x squared is equal to 2 over x cubed. Cross multiplying and rearranging gives me 2x cubed minus 2x squared is equal to 0. Now, obviously, I can divide through by the 2 at some stage, so I'm going to do that now. X cubed minus x squared is 0. X into x squared minus 1 is equal to 0. Remember here, I'm just working with the second derivative. So solving that without thinking about this particular function gives me 3 solutions, except that we know that 2 of them are not valid, right? Because x must be positive, so those 2 go away. So the point of inflection will happen where x equals 1. Now we need to get the y coordinate, right? So this is step 4. So the function is 2x minus 1 over x minus 2 ln of x after I've simplified it, after I've cleaned it up. So here we get y is equal to 2 minus 1 minus 2 times log 1. This is 0, so y is equal to 1. So point P is equal to 1, 1. Now the next thing we've got to do is find dy by dx, or find the gradient at that point. So dy by dx was equal to 2 plus 1 over x squared minus 2 over x. And at P, it's going to be 2 plus 1 over 1 squared minus 2 over 1, which gives me 1. So M is equal to 1. And that means that my function will be y equals x plus c. And we can substitute in the point 1, 1 to give me, well, it's pretty obvious when you're looking. So y equals 1 plus c. C is equal to 0. And my line is very simple. It's just y is equal to x. And that's the equation of the tangent, right? But I just want to show you what that looks like on the graph. So that's the equation of the tangent at P. And here it is here. So that's the graph to check. Up here is just the graph of the function. So it's a pretty funny looking one. You have to really zoom in on GeoGebra to see what's going on and that there is a point of inflection there. So the best way to do that is if you take your hand, you can't see me doing this, but take your hand and cover up like half of the picture. So put your hand right about at x equals 2 and then move it backwards to get it at x equals 1, and then shift your hand over. I'm really not making a lot of sense here, right? So here's x equals 1. Just try and do that and just look at the curvature changing, because that's what a point of inflection is, around that mark. And then if you go down to here, I've put the inflection point in and zoomed in a little bit more, and you can see that the concavity is changing at that point. So there you go. I'll try and do some of the other questions in the papers over the next week or so before Christmas, but it depends what I feel like doing and how much of a holiday I feel like having. If you've got any you really want me to get done, let me know. I remember that there's one in here that I think was a bit bad, something about a turning point or a stationary point where I didn't like the question much. So I don't know, I might put off doing that one till I've cheated and had a wee look at the schedule. Thanks for watching, and have a good holiday.